So for Fibonacci, there's many ways you could solve this, but this is just kind of the way that comes to mind for me. And if you're unfamiliar with Fibonacci, it's like starts with 1 1, and then you add the two previous, so you get 2, and then you add the two previous, and you get 3. 2 previous, you get 5 and 8 and 13 and so on. And this kind of sequence here is found often in nature, like for instance in a conch shell or whatever it's called. This, like, the ratio of the curve follows the Fibonacci sequence, and like different shapes also kind of follow that sequence. So it's kind of a magical discovery in mathematics. And the way that you would solve this guy is, well, the way that I would do it is I would have two variables, f and s, and I would set the first one to f, the second one to s, and then I would print those two out, because that's the way the program should go, print out 1 1, and then we have a loop, and inside the loop I'm going to have this new variable called sum is equal to f plus s, right? So here sum is going to equal to 2 f plus s, and then after that happens, well, the loop is going to execute again, and the next time I want f to be equal to this and s to be equal to this, right? So that when I add the two, it will give me 3. And so how do I get that done? Well, f needs to be that, s needs to be that. So f needs to be equal to s. S is old value, and s is going to be equal to sum's previous value. Of course, we need to print line sum. So this would print the 2, f is 1, s is 2, and when we come back up, it's going to be 1 plus 2, and sum's going to be equal to 3. And then it's going to adjust f and s and print out the 3. Then it's going to add the 2 and the 3, and then adjust f and s and print out the 5, and so on. So this would solve the Fibonacci, the sequence problem.